Right, so before I start going on about series circuits, I want to start by looking at these circuit symbols. So we've got a page here full of circuit symbols, the ones that you need to know for GCSE. There's some really easy ones, obvious ones like the open switch and the closed switch. You might remember those from previous years. You will have looked at circuits before in your Key Stage 3 most likely, so those two are pretty obvious. Filament bulb, you might already remember that one, but then there's other ones that you might not have come across yet or might not even heard of, like such as the diode or an LED or that sort of thing. But you'll get there, you'll learn this. We'll use them in a lot of circuit diagrams in the next few videos, so hopefully you will learn them from that. Right, so let's go on to series circuits now. Series circuits then. So what does the word series actually mean? Series means if you do something in series, if you're doing things in series, you are doing them one after the other. Yeah, it's the exact same thing with series circuit. The current in a series circuit goes through one device, then through the next device, then through the next device, one after the other. Okay, so what does that look like in a circuit diagram? So well, let's put a cell in to start with, and then we can draw a wire. I'm going to put a switch down here. It's currently an open switch, so let's put a bulb in down here. Filament lamp, filament 2 there, and so on. Okay, so there's my series circuit. Hopefully yours will look better than mine when you draw yours. Yeah. In fact, let's just have another go at that bulb. There we go. Right. So there's my series circuit. So it starts at the current is flowing from the cell through the switch. Well, it's not actually going to flow at all at the minute because the switch is open. Yeah. So if the switch is open, no current can flow. Electrons cannot move through the circuit. Remember, that's what current is. It's electrons moving through the circuit, and they can only move through complete circuits. So let's make it a complete circuit. Let's close the switch, and now we've got electrons moving around the circuit through each bulb, and then back to the cell again to collect some more energy to flow around again. Okay, so let's talk about current in a series circuit. So current, remember, flow of electrons in a circuit. In a series circuit, they've only got one route to take, so the current is going to be exactly the same no matter where you measure it. So I could put an ammeter, let's say I put an ammeter here, okay, there. That's going to measure a current. If I put the ammeter there, it will measure the exact same current as an ammeter here. Yep. Or between the bulbs or anywhere in the circuit. I can put that ammeter literally anywhere and it will give me the same reading. Yeah, series circuits, the current is the same everywhere. Okay, so let's talk about the potential difference in a series circuit then. So potential difference, remember, is the amount of push or the amount of energy that we're going to give to the electrons that are flowing around the circuit. Now that energy needs to be shared between all of the components in the circuit. So the two components in the circuit that we're going to share the energy between are the two bulbs here. Okay, so we've got bulb 1 and bulb 2. Okay, I don't know why I've done Roman numerals, but I've done Roman numerals. So some of that energy will be given to bulb 1. Some of it will be given to bulb 2. Okay, the amount of energy each bulb gets will depend on its resistance. Yeah, bigger resistances will take more energy to push that current through them. So if one of the bulb had more resistance, then that bulb will take more of the potential difference from the circuit. Now, the potential difference, remember, is shared. Okay, so if these bulbs are identical, then each bulb will get 50% of the potential difference from the circuit. It will use up 50% of the potential difference. Yeah. So bulb 1 will take, let's say this was let's make this a 6-volt battery. So bulb 1 will take 3 volts of potential difference. Bulb 2 will take 3 volts of potential difference. If there was 3 bulbs in the circuit, how much potential difference would each bulb have to take? Well, if there's 3 bulbs, it's got to share it 3 ways. Okay, so they'll all 3 will get 2 volts of potential difference. 2 plus 2 plus 2 is 6. Yeah. Right, now something else that we need to know is how we measure potential difference and how we measure the current in a series circuit. So we've talked about a current. We measure that with an ammeter. You saw that I put the ammeter in series. Yeah. So the job of an ammeter is to count the amount of charge flowing through it every second. yeah, so it has to be put in series because it has to allow the current to flow through it. Voltmeters measuring the potential difference have to be placed in parallel. Okay, so if I put a voltmeter here, this will measure the voltage across bulb 2. If I put another voltmeter here, this will measure the voltage or the potential difference across bulb 1. Yeah, so that gets measured in parallel. Okay, so each one of those voltmeters at the minute will read 3 volts, assuming the bulbs are identical. If I then put a voltmeter across this, the whole thing here like that, then how much potential difference would that voltmeter read? The third voltmeter. Well, it's measuring the potential difference used by both bulbs this time, yeah, because it's across both of them. So the potential difference used by both bulbs is the full 6 volts from the battery. Okay, putting a voltmeter here is exactly the same as putting a voltmeter here. Right, so let's have a look. So there's a follow-up question for you to have a go at. I will put the answers in. I'll put the answer to that in the description of the video. So have a go at that, see what you think, and I'll see you in the next video.